In today's video, we're going to look at double integrals. So we solve an example under it, and this question says use polar coordinate to combine the sum of these integrals into one double integral. Then we have to evaluate that double integral. So suppose x equals y, and this guy, which is square root of 1 minus x squared, equals y, which implies x squared plus y squared equals to 1 when we take the square of both sides. So for us to convert to polar coordinate, we must recall all this property. Polar coordinates, all this property says x squared plus y squared equals r squared, and the same thing as, and also x equals to r cos theta and y equals to r sin theta. This property is very useful in converting to polar coordinates, so we are going to utilize all this property. Also, x squared plus y squared equals to 1, which is the same thing as r squared. We have r squared equals to 1 here, so r equals to 1. Let us consider this guy also, which is square root of 4 minus x squared. Let's set this to equals to y, so we have x squared plus y squared equals 4. And our r squared equals to this guy, so we have r squared equals to 4, so r is 2. So we have two radius, which implies our r lies between 1 and 2. And in polar coordinates, we must also recall that the area, which is elemental area dy ds, is the same thing as r dr d theta. When we convert it to polar coordinates, we are going to use this property also. So let's sketch a figure. Let's call this figure 1. This is our s plane. This is our y plane rather. Sorry. This is our s plane. Let's call this 1. Let's call this 2. This minus 1, minus 2. This 1. This 2. This minus 1. This minus 2. Just a rough diagram, rough sketch. So our first radius is 1. We're gonna have 1 here. Actually, it is closed. We have 1. Second radius is 2. We have 2. So, and from this guy, y equals to s, which is a straight line, it passes through the origin. So we have, it's passing through the center of the origin, is y equals to s, a straight line, which implies our angle is between 0 and pi over 4, which means theta is between 0 and pi over 4, because the whole angle here is 90 degrees. Then the half of it will be pi over 4, which is half of pi over 2. So we can now evaluate our double integral now. So we're gonna have on double integral now will be from evaluating from let's say 0 to pi over 4 and 1 to 2, and to convert sy dy ds to polar coordinate, we're gonna have something like this: sy dy ds, which is the same thing as our s is r cos theta and our y is r sin theta, and dy ds is r dr d theta. So we multiply all these guys together. We're gonna have r square r cube. We're gonna have r cube sin theta cos theta r dr theta. So we're gonna have r cube sin theta. Oh, there's cos theta here. There's cos theta. Sorry. So that you can clearly see it. There's cos theta. So we have r cube sin theta cos theta dr d theta. When we do our integration with respect to r first, we're gonna have 0 to pi over 4 r raised to power 4 over 4 sin theta cos theta. Evaluating from 1 to 2 the theta. We fixed sin theta cos theta and we integrate with respect to r. So when we plug into here, we have, let's say we have 0 to pi over 4. That's 2 raised to the power 4, that's 16 over 4. Sin theta cos theta minus, when we plug in 1 here, we're going to have sin theta cos theta over 4 the theta. So when we do the subtraction, we're going to have 0 to pi over 4, and that will be 15 sin theta cos theta over 4 the theta. You can take this 15 over 4 outside because it's a constant. So we're going to have 15 over 4 into 0 to pi over 4 sin theta cos theta d theta. Well, in this case, we have to recall that sin 2 theta over 2 equals sin theta cos theta from trigonometry. So in this case, we are going to replace sin theta cos theta with sin 2 theta over 2 so that we can evaluate our integration directly. So we have 0 to pi over 4 here, sin 2 theta over 2. Actually, we will call this from trigonometry. So the theta, when we take this half outside, we have 15 over 8. We have 15 over 8. So when we integrate 0 to pi over 4 sin 2 theta the theta, when we do integration, we're going to have 15 over 8 into minus cos 2 theta over 2, evaluating from 0 to pi over 4. So, which is the same thing as minus 15 over 16 cos 2 theta, which is when we plug in pi over 4 here, we're going to have cos pi over 2. When we plug in 0 here, we're going to have cos 0. So we have minus 15 over 16 into 0 minus 1. So we have 15 over 16, which is our final answer. Thanks for watching.